Hello, everyone. I'm kind of excited. This is an extreme talk. So usually I would spend the first 5 minutes talking about why JavaScript is cool and why you might want to learn it. But obviously, if you're here, you've already decided that for yourself. So I can skip over all of that, and I can go right into talking very quickly about lots and lots of stuff. One thing I do want to say about JavaScript is that I think a lot of people have this impression that JavaScript is this really unpredictable and weird language with all these kind of crazy caveats, and you can never really truly understand it, especially people coming from a Python background. And I think the reality of JavaScript is actually it's a small, really simple language. It's really pretty predictable. All the implementations actually act very much the same. It just has some weird things that might break your intuition. And once you understand those little weird things, it becomes not always the perfect language by any means, but a totally understandable language. And I also think that a lot of your intuition as a Python programmer is really transferable to JavaScript, and it really makes it a pretty easy language to learn. Once you get over, so I'm going to talk about all the places where it's not an easy language to learn, all the places where that I've found where you have to understand what it's doing and try to put aside whole questions about why it's doing that. I would also love to see more of the kind of Python attitude towards programming in the JavaScript community. So if you do basic translation, I'm hoping everyone has some familiarity with JavaScript, because I won't go over kind of the basic details. But a lot of things look very equivalent in both languages. You just add some semicolons, some braces. There's a couple keyword differences. A lot of the keywords are the same. The literals are the same. Strings look the same. It has a notion of truthiness and falsiness, just like Python does, except that empty arrays and empty objects aren't false. But the data structures are kind of I think they're always one of the core parts of any language, and what you spend most of your time is just futzing around with data structures. So I'm going to spend most of this time talking about the core data structures of JavaScript, of which there are very few. But there's something kind of like Python's list, and then like dict. So one of the things I like about Python, it has these kind of very light objects that if you don't decide you need to build a class and a special object, you can just start passing dictionaries around. And it's kind of this very casual way to start passing structured data. And JavaScript, I think, is kind of interesting because it takes it even further. So everything is a dict and everything is an object. And so as you see, the literals are very similar. The keys are always strings, and you can quote them or not. It's just a kind of syntactic matter. As long as it's a valid identifier, you don't have to quote it. And you can use it in a lot of ways similarly to how we tend to use dictionaries, except all the kind of convenient methods are gone. If you look at this form, where traditional kind of dictionary access, in JavaScript it is exactly equivalent to this form. There's really no difference whatsoever. And another kind of general pattern in JavaScript is that exceptions are relatively uncommon, and when they happen, it's usually it's never for a good expected reason or something that anyone tends to catch. So for instance, when you try to access a key in JavaScript that doesn't exist, you get back the undefined object as kind of a signal that this does not exist. In general, I think when you look in JavaScript, you'll find that exceptions, though they work very similarly to how they work in Python, they're different in that no one ever uses them. Or if they do, it's kind of a huge panic, like everything dies. Something went wrong. And then a little bit about functions. Again, it has a very similar feel when you look at an equivalent Python and JavaScript function. And this is a relatively complicated function. Variable declaration is very similar to Python, except the way you declare it is the opposite. So in Python, if you assign to a variable, it automatically becomes a local variable unless you kind of say otherwise. If you use a global keyword to say that this is actually a global variable, or in Python 3 there's a non-local keyword, which says belongs to one of the parent functions of this function. In JavaScript, it looks, you say that something is a local function by using var, and if you don't say that it's a local function, then it keeps looking into parent and parent scopes, so the default ends up being the window object. Arguments in JavaScript. Again, kind of going with this idea of everything just kind of willy-nilly just works. There are never any required arguments in any JavaScript function, and you can always pass as many arguments as you want into any JavaScript function. So if you declare, 10 arguments in your function signature and someone only passes in one, you're going to end up with all the other ones being assigned to undefined. And only if you actually check them there'll be any way to detect that. And again, you can always pass extra arguments in here. And there's a magic variable called arguments that contains all the extra arguments. It contains all the arguments, including the ones that you defined. If you actually use that arguments object, though, it's important to be careful. There are a lot of things that are almost arrays in JavaScript. That is, they walk like a duck, they have a length, you can index them, but then as soon as you start looking a little bit closer, they're not really arrays, and everything kind of breaks. And arguments is one of those magical objects. So I said with attribute access, if you access an attribute that doesn't exist, you get back undefined. Undefined, I think I've seen a lot of code that treats undefined as though it's this magical sense, because we kind of think of exceptions or something as being this, like, we're exiting the normal code path. In JavaScript, the undefined object is just an object. It's similar to null in that you have an object that has a singleton and has a special meaning. You aren't allowed to get any attributes on it, but it is really just an object. So you can compare other objects to it. If you're checking if an attribute is defined on something, just using this simple thing, is it equal to undefined? The reason I think that people tend to become confused about it is that there is this one special form here, which normally when you access a top-level variable, just like in Python, you'll get an exception. But if you use this one special form, you can test if a variable exists, which is type of won't give you that exception. So I'm going to go a little bit more into objects. You probably heard about JavaScript being a prototype-based language. People get really excited about this prototype thing, and most descriptions of this start out with this question about philosophy and radically different object-oriented notations, and some people will go on to everyone knows how classes work, and so prototypes that sucks, and other people are like, oh, isn't JavaScript this wonderful lightweight language, and that's why it uses this totally appropriate thing. All of that is a really bad way to start getting into what prototypes are, because they're really just a simple mechanism for how objects work in JavaScript. And it's really quite easy to understand how prototypes work, and then once you understand how prototypes work, you can decide, do I think this is a terrible feature or a great feature? But you don't have to kind of shield yourself from the knowledge of prototypes just because you have a certain object-oriented opinion. And anyways, object-oriented programming is that's yesteryear anyways, so nobody cares about it. So the way objects work, if you look at this function point, this is equivalent to the under init in Python. And it's very equivalent in that when you're creating a new object, the object first gets allocated, and then it gets initialized by this function. Just in the same way that init doesn't have a return value particularly, it initializes an object that has already been created. The only difference is because this point function, as you can see here, is just a function, JavaScript doesn't know that it was specially meant to be a constructor. So the only way that you can actually tell JavaScript that I really meant this as a constructor is the new operator. And this would be something that as a Python programmer you're going to constantly get confused about because our fingers just know how to instantiate a class by calling it. And if you call this function, it'll work perfectly fine. Oops. Oh, no. It'll work perfectly fine, but it won't do anything like what you would think it would do. So in JavaScript, all functions always have a this variable defined for them. So even if it seems like a top-level function that has no object-oriented thing going on with it, this will still be defined. And the default value for this is the global object or the window object in a browser. And so if you run this code, and this is bound to the global object, you'll have actually just defined a global x and a global y variable, and you'll have returned nothing. And so later on, you'll get some sort of bad exception that will probably be very confusing to you. So as a Python programmer, I think it's essential that you always put this at the beginning of every function definition to test if you are getting something wrong. So I want to emphasize that really prototypes are not at all dissimilar from Python classes. So this is a simple class. See, it has a class attribute. You can assign to the class to an attribute, and it kind of covers up the class attribute. It doesn't change it, but it assigns it on the instance. When you look up an attribute on an object, it first looks at the object and sees if the object defines that attribute. And if not, then it looks in the class, and it looks in the superclasses. So JavaScript works in very much the same way, only what we call a class, it calls a prototype. So when you do this new point, you're creating an object and you're setting its prototype to whatever this prototype attribute is on the function that you're using as a constructor. So that means that when you take this P object and you do an attribute lookup, first it's going to see, does the P object define that attribute itself? And if not, then start looking in the P's prototype. So now you have the value of Z, and the value of magnitude, which again are just attributes. And the fact that one happens to be a function, it's not special. And you can continue to look into your prototype's prototype and so on. The biggest difference here really is that where on Python you have a special type of object, which is a class, in JavaScript you just don't have special types of objects. They're all kind of similar. Which you can overthink it a lot and get into the spirit of it, but it's really just a very simple structure. The one thing where that ends up being different is that, of course, if you understand a lot of Python's internals, where you fetch an object from can change the way that object works, using descriptors and bound methods and things like that, and JavaScript does not have that. And I'll talk a little bit about how it gets around that. Oh, sorry. So this is how you do it with prototypes. There's also another pattern in JavaScript that is pretty common, which does something that from the outside looks exactly the same, but is not using any of the prototype machinery. In this case, we're declaring a literal object right there. We're giving it all the attributes, and we're giving it a method. And the method doesn't use this. It uses self, which is actually, that should be a var self. And it would be very broken, actually, without the var self. But it uses closure as a way of having this idea, kind of a bound sense of context, which is another very common pattern. And so this is essentially a factory function, whereas the other one is more like a class. In Python, we have that same kind of distinction. It's just conveniently you call both of them in the exact same way in Python. And so it's very convenient to sort of substitute factory functions for classes. And unfortunately, you have to remember which is which in JavaScript by using the new operator. Now, you could do exactly the same thing in Python, especially with Python 3's non-local attribute. It's just it's syntactically unappealing and culturally not really liked very much. But this is really the equivalent to this second example here. So just kind of reviewing prototypes. New allocates an object. It sets the prototype based on the constructor's prototype attribute. And that sets up kind of an inheritance of attributes. One of the unfortunate parts is that the inherited attributes are exactly equivalent to all the other attributes, which means that things like the in operator means that you would, if you do, for instance, magnitude in point, it's going to be true because the prototype defines magnitude. This is perfectly fine for something more like objects. But when you start using data dictionaries, it becomes really awkward. Because, of course, dictionaries and objects being the same thing, you kind of have this overloaded semantics. So I said in Python there's this particular way that you get a function from a class, and that turns it into a bound method. And JavaScript doesn't have any sense like this. It has this object, which is very much like an argument to the function, right? It's as though every function always has a first argument that is this. And unlike Python, where some functions take a self argument and some don't, everything always has a this argument, but the way it's figured out is really unintuitive for a Python developer. So the core way this is figured out is JavaScript looks at your expression, and if your expression is a value of some sort, and then a dot, and then a method name, and then parentheses to invoke a call, it knows it's a method. But all those pieces have to be together in one place. You have to have the value, dot, method name, call, in order to turn it into a method call. So this is something that Python programmers would be really apt to do and will totally not work. As soon as you get this attribute from an object, what you get is a function that no longer has any context or any notion of what this is, and when you call it, this will be right back to window again, essentially. So there's no bound objects, and it's syntactic. If you use this self pattern, you would get around that, but it has the problem that you have to know that you are using that pattern. So if you're working with other people's code, it's really important as a caller to be sensitive to this distinction, because somebody else's code might not be safe against this kind of binding. Going back to the self example, it's a pattern that you'll see pretty often in JavaScript, is using something like a self variable and a closure as a way of creating private variables. So you can actually do this again in Python, like the other example I showed. It's just a very uncommon pattern. But in JavaScript, it's useful to recognize this pattern. It's become particularly popular recently. And in this case, for instance, if you see x and y are these local variables, and they're assigned as, or used as local variables, and they are not in any way exposed. These two functions here are essentially getters. So this would create a real read-only point object that nobody else could change either the x or the y. And this has also become a really common pattern for modules. If you look at this, it creates a big closure right here. In other words, a function scope. And inside the function scope, anybody inside the function scope can see this private function. But nobody from the outside can see it. They can only see what you have explicitly exposed, in this case, this public variable. This is really common. I find it really difficult for unit testing. And really, again, Python has some of these mechanisms. Of course, it's much more syntactically awkward to use them. But there's no important reason in my mind why JavaScript is different from Python in terms of rules like we're all consenting adults, and maybe if you start looking at weird private variables, then maybe you have a good reason to do so, and if you don't, then that's up to you. So this is someplace that, while you will see kind of a different culture, I think it's fully appropriate to use kind of your Python intuition about privacy. Another concerning place when you are using this is with these kinds of closures, because again, since every function essentially has this implicit this argument, your this here, which this is a method on the sum object, down inside this other closure, this is going to be lost, and you're going to it's probably going to be the window object, or it might be some other kind of random thing. Whatever the caller wants this to be, that is what this object will be, and the caller really has all the control over that. So in this case, when you really want to know what you're calling, you have to use the same self pattern again, where you use a closure to kind of fix self in time and then call on that later. So showing how you can control the this argument with JavaScript. Of course, you can use that special syntax where you have object.method and then call it. There's also this method on all functions, the apply method. And the apply method takes a argument of whatever you want this object to be, and you can pass in anything there. You could pass in a newly allocated object. This can be bound to, for instance, a DOM method or a DOM element. And then you pass in an array of arguments, which is similar to Python star args, except, of course, doesn't have kind of quite the syntactic convenience. And so this is really equivalent to a logging decorator that you might see in Python. And hopefully it looks really familiar. You create this inner function that wraps the outer function, returns the value exactly, but just might modify some values, or in this case, does a little bit of logging. This is a pattern I haven't seen in JavaScript, but it's one of what I think is a really nice kind of invisible feature of Python that is entirely applicable to JavaScript as well. I'm going to talk briefly, but in JavaScript, similar to, say, in Ruby, you can kind of monkey patch everything. This is again where your Python intuitions, I think, will be helpful, because monkey patching, especially monkey patching objects in JavaScript, really breaks everything. If you see the in operator, if you assign something to object.prototype, all of a sudden everything in the system has that attribute. If you were fetching some JSON over the wire, everything will always have that attribute. So my primary advice is stay away from libraries that do this. MooTools would be an example of a library that does this. I consider it kind of rude. But if you have to code really defensively, then you have to put in a ton of calls to has-own property. Last, I'm going to kind of finish up talking a little bit about types. Types in JavaScript are one of the places where people get really... it's a great way to demonstrate why JavaScript is crazy. And people kind of focus on it because it doesn't make much sense. So JavaScript has a notion of primitives, which are things, numbers, strings, well, mostly numbers and strings, and Booleans. And then everything else is an object. So arrays are object, etc. So it has one big bucket for all the objects in all the entire system. And then these kind of notion of primitive types. JavaScript also decided to copy a feature from Java. I can only imagine that this was kind of a very naive sense of trying to copy Java at a time when Java was supposed to be cool. So Java has this notion of primitive values and boxed values, where, for instance, you might have an integer in Java, and the value kind of sits there without any metadata, nothing that says this is an integer. And it's only because you use it, you have the static typing, which says, I know this variable is an integer, therefore everything can kind of work with it. But as soon as you lose that syntactic kind of tagging of an object, you box it. You add the metadata that says this is really an integer. Now JavaScript actually works just like Python does. Everything is an object. Strings are objects. Booleans are objects. There's no need for boxing and unboxing. There's no need that everything always carries this metadata around. But they created classes for all these primitive types, and the way that they're implemented is that they are kind of these object wrappers around the primitive types. So you can create a new string, and the type is going to be object, and it's going to compare equal to a normal string, but it won't really be a normal string, and there's a lot of ways in which it will act slightly differently. And in order to make this kind of work, there's all these kind of crazy coercion rules. One of the coercion rules is that equality kind of tries to look at the real value of the underlying object, and does this variety of kind of weird traversals to figure it out, and as a result, it's very confusing. JavaScript has an equal, equal, equal operator, and the equal, equal, equal operator, or the triple equal, is very similar to kind of to Python's is operator, in that for objects it always does identity, and then for primitive values it does value comparison. So it's become pretty common for people to strictly use equal, 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 and the also not equal, equal, which is the equivalent, not value, for all comparisons. And there's really no downside, except that you lose this kind of boxing ability, which is just a crazy and terrible feature. A lot of whenever you look at examples of how JavaScript is crazy with addition, it's the same pattern of it's trying to kind of coerce things, and it coerces them into strings or numbers depending on the context when you use addition. JavaScript arrays. I'm not going to say a whole lot about them because they're just really terrible. So these are kind of examples of how different things work with JavaScript arrays. You don't get the nice slicing objects. There's not a good way to iterate over them. There's a lot of different people who've experimented with different techniques, but I really think that it's best just to stick with plain old for var equals I equals 0, etc. There's for each, which I find kind of problematic. For instance, you pass on this function, but now all of a sudden continue and break don't work. There's no iterator protocol. There's a lot of things that look like arrays but aren't exactly. And there's this whole thing of the fact that arrays have properties that are integers, but they also have other properties that are methods. It's rather confusing. One of the particularly sad things is that you can't test for containment. JavaScript. Underscore.js is a nice library if you want to have some sane functions on arrays that'll feel good to you. When I asked about questions about this, some people were interested in knowing about the DOM in JavaScript. And I wanted to stay away from that because the DOM is essentially a library. It's not JavaScript, the language itself. It's just this library that's been provided to JavaScript. And it's really, obviously, if you use mini-DOM in Python, it has all the same kind of weirdness. Really, that's all C++'s fault. Like that's all of those aesthetics applied to JavaScript. And maybe that's a problem of JavaScript in that it doesn't have enough willpower to reject poor applications of libraries towards it. But everything that's weird about the DOM really shouldn't be blamed on JavaScript. One thing that is kind of ironic is that you can't implement the DOM in JavaScript because JavaScript does not have anything like a property where you can have a dynamic attribute. There are features being added to add these things, but at the moment, because the DOM and some other libraries that are provided to JavaScript use some of these features, you kind of don't get the same thing. So if there's time, I'll be taking questions. There'll be a couple minutes of time. So if you do have questions, think about them. There are some things coming up in JavaScript. I think JavaScript shows the danger of a lot of different runtimes. So while there's actually been, over time, a lot of improvements in JavaScript, it's really hard to actually use them, and because everyone's kind of like slowly adding these new features. So a lot of the features are actually very Python-inspired. Some are like getters and setters, just straightforward. Proxies allow you to implement kind of complicated objects that implement any kind of interface that you might want. And then you also get things like array comprehensions, which are just like our list comprehensions, and maybe somewhere along the line we're going to get something like iterators in JavaScript. And then lastly, I'll put in a little plug for a language called CoffeeScript. CoffeeScript is essentially another syntax for JavaScript. It will feel very familiar to you as a Python programmer. You really have to understand JavaScript entirely before you use CoffeeScript. There's no point, it doesn't save you from anything because you still have to look at the compiled JavaScript, but it'll look very familiar to you. And mostly, once you understand JavaScript really well and you try to use CoffeeScript, you're like, yes, this is no longer a really terrible and painful environment in quite the same way. So it's also bizarrely white space sensitive, more white space sensitive. Like if you put a new line in the middle of an expression, that has serious semantic meaning. So it's novel. So that's it. Thanks. Only 1 minute for questions, so I'd be happy to talk about things out in the hallway afterwards. But open space is a good place. And maybe we'll have a JavaScript open space. But one question, maybe.
One of the things that really helped me learn Python was the interactive interpreter. What do you recommend for people learning JavaScript to actually get immediate feedback on syntax? And does this work, or am I mistaken in something?
There is, all the browsers have, well, there's Firebug and Firefox. There's now the web console. The developer console in Chrome is pretty nice. These work well. You have an interactive prompt with Node, which is a command line thing, but I find it a little bit less usable. So I would advise browser ones.
all of your example classes were flat, what does inheritance look like in this prototype-based inheritance world?
When a prototype has a prototype, then that's a superclass essentially.
And so it just keeps looking, prototype, didn't find it,
Yeah.
prototype, didn't find it, prototype, didn't find it. Okay.
So you demonstrated creating classes with new and talked about the problems with that and how you have to have this guard in the front of every class, essentially. And then later you talked about doing it with closures. And when you do it with closures, the way like Douglas Crockford does it in JavaScript, the good parts, you don't have to worry about checking this at the beginning of every function. Do you think that's a good enough reason to always use the closure method or not?
I mean, you lose inheritance, but I don't see inheritance as a feature that almost anyone uses in this context, so it's not a big problem. There might be some performance problems, especially with memory usage, because if you have a bound method that is using closure, every instance carries around the copy of that bound method. Mostly, you have to be comfortable with both things because you'll be using libraries that use both techniques. That's it. So, thank you.